of values for 4 aqueous solutions at 25 degrees. Okay, let me redraw this table here. So this is solution A, B, C, and D. I have a line tool, right? Yes, I do. That makes my life so much easier here. It makes your lives easier as well, because you can see what I'm writing here. So A here. So I have HOH. Oh, now my lines are just not straight. That's so awkward. Why are my lines not straight here? Whatever, it's fine. Okay, for the sake of this, it's fine. Okay, I have, this is, let me scroll up here. So this here is H plus OH minus, I realized I forgot a line here, unfortunate. So let me do that. Extend this line. Okay, hope you can all see that. I have pH and POH, right? Okay, that's fine. So for the first one, I'm giving the solution. So I'm gonna work. Maybe I'll work horizontally. So I'm given my concentration. These are in concentrations of my hydrogen ion here. This is H 8.3 times 10 to the negative 12 molar. So again, how would I solve for my let me solve for my pH first. How would I solve for my pH of the solution here? So I would solve for my pH if I know, and I'm scrolled down here, if I know that, I'll do some blue, pH again equals negative log of my H plus ions, right? So in this case, pH here equals negative log of, I have is 8.3 times 10 to the negative 12, right? So 8.3 times 10 to the negative 12 molarity here. And this here, pH would now equal, so let me just plug in my calculator, negative log of 8.3 times 10 to the negative 12. This here will equal 11.08. So that here is my pH, which is great. So I can plug in my pH here. This is 11.08. Again, POH is simply just POH, or in this case here, pH plus POH has to equal 14, right? So again, another useful formula here, and I'll do this in blue again, is the sum of pH plus POH has to equal 14. So in this case, if my pH is 11.08, my POH is simply 14 minus my pH, right, which is 11.08. So POH would equal, this is 2.92, right? 2.92 would be my POH here. This is 2.92. That's good. And then if I figured out my POH, I can obviously solve for my hydroxide ions, right? So I can solve for my hydroxide ions using this here. So let me box the formulas I'm using here. So I use this one, I use this one, and I also I have this one last one I'm using. I'm going to use this one here. This is POH equals a negative log of my hydroxide ions here. In this case, POH is 2.92, right? So it's 2.92 equals negative log of my hydroxide ions. I need to move negative log to the other side, right? So if I move this to the other side, I would get hydroxide ions, or the concentration of my hydroxide ions in square brackets here, equals, this would be 10, the base is now 10, right? To the power of negative 2.92. And this here will equal, I'm going to shout 10 to the power of negative 2.92 would give me 1.20 times 10 to the negative 3. 1.20 times 10 to the negative 3. Which means this here is 1.20 times 10 to the negative 3. Sweet. So basically what we have to do is we do the exact same thing as we go down, right? As we go down the column here. So let me just draw it out for you. This is 5.0 times 10 to the 9. This is 3.37. This is 8.26. So again, the order doesn't really matter in terms of how you do this. I usually do OH with OH and pH with pH just for simplicity's sake. So let me do OH and POH in column in solution B here, right? So again, I'm using the exact same formula. I'm going to use this one here. I told you I would box it for you. I would use this formula here to figure out my solution, right? So POH would equal negative log of this number here, right? Of 5.0 times 10 to the negative 9, which is the concentration of our hydroxide ions. In this case, 5.0 times 10 to the negative 9 would give me 8.30. So I can simply put 8.30 in our POH column. Whoops. 8.30. I can simply take 14 minus the POH to figure out my pH here using this formula here. So let me use 14 minus the answer. 14 minus 8.30 would give me a number of, this is 5.70 for my pH, 5.70. And then with our pH, we can simply solve for the hydroxide ions right here, right? So again, I'm using this for this formula here, but then I have, let me do this in blue again. I have pH, which is now 5.70 equals a negative log of my hydroxide ions, right? Oops, sorry. Of my hydroxide ions. And I have to move negative log to this side, so H plus would equal 10 to the power of negative 5.70. Again, H plus would equal, this here is 10 to the power of negative that, which is 2.0 times 10 to the negative 6. So this here is 2.0 times 10 to the negative 6. Yeah. Let me just double check something. Yeah, cool. So this here is correct. That's fine. And then all I have to do with the solution C again. I'm giving my pH, so let me solve for my, I can solve for my H plus or my POH first. It doesn't really matter. Let me solve for my H plus here. So I'm taking the, again, 10 to the negative H plus, 10 to the negative pH here would give me my solution, right? So I'm doing, let me erase this to make room. But I can basically say that the concentration of H plus ions equals 10 to the power of negative pH, right? So in this case, my pH here is 10 to the negative 3.37 for solution C, as you can see here. And this here would equal 10 to the power of negative 3.37. This here equals 4.27, sorry. 4.27 times 10 to the negative 4. This is molars. And as you can now do, I can simply do 14 minus the pH to get my POH. So I'm going to do that. 14 minus 3.37. So I would get 10.63 for my POH. And simply I can take the negative log, or exactly, not the negative log, but I can take, I can use this formula here. And OH minus equals 10 to the power of negative POH, right, to solve for that. This is simply just a rearranged form of this formula here. So again, the POH here was 10.63, so 10 to the power of negative 10.63 would give me the concentration of my hydroxide ion. So if I did that on my calculator, I would get 2.34 times 10 to the negative 11 molars. And then finally for solution D, I'm doing the exact same thing. 14 minus the POH would give me my pH. So 14 minus 8.26 would give me 5.74. And then I'm simply just doing, redoing these formulas here. I'm using these two formulas. H plus equals 10 to the power of negative pH. So 10 to the power of negative 5.74 would get me my answer, which is 1.82 times 10 to the negative 6 molars. And then finally, I can do 10 to the power of negative POH, which is 8.26 to solve for my hydroxide ion. So negative 8.26 here to solve for my solution here, which is 5.4 or 5.50, sorry. 50 times 10 to the power of negative 9 moles. So this here completes my entire table of these solutions. So it's kind of wonky because I can't really see it. But let me just verify my answers real quick. This here is 1.23 times 10 to the negative 3. They wrote 1.20. Oh no, 1.23. That's good. 11.08, 2.91. I have 2.92. That's close enough. 2.0 times 10 to the negative 6. That's good. They gave you this 5.69, 5.70, and 8.30. That's good. 4.27 I have here times 10 to the negative 4. They have 4.2. That's fine. 2.34 times 10 to the 11, 3.37, 10.63, and then finally 1.81. I have at 1.82 times 10 to the negative 6. They have 5.4. 2 times 10 to the negative 9. I have 5.5, 5.74, and 8.26. This here is my correct solution. So great solution. And analysis, because what they did was they also wrote the